today I'm going to be talking about interference and diffraction. Interference occurs when two waves interfere with each other and create a resultant wave that is either a higher or lower amplitude. There's two types. The first type is constructive interference, and it occurs when the crest of two waves meet with the same phase, and so it makes the crest of the wave 2 times as large. And then destructive interference is when the two waves meet at opposite phases with the same frequency, and so it creates a resultant wave that is less than the original amplitude of the first wave. This is going to be one of the waves, and then this is going to be another wave, and they're going to be interfering. So when both of these waves are interfering, it's going to create a wave that has twice the amplitude but the same exact frequency as before. So as you see here, the frequency is the same, but the amplitude here is twice as large because you're having to add the amplitude of this wave plus the amplitude of this wave. So in this example, I'm going to have this wave interfering with a wave with, if you look at this one, the crests here are matching the troughs here. So when you add these two waves together or they interfere, it's going to create a wave that is just a flat line. Now I'm going to talk about diffraction. Diffraction is a phenomenon that occurs when a wave encounters some sort of obstacle. This can occur in any type of wave. A water wave, a light wave, sound waves, even electromagnetic waves. Now I'm going to explain the different parts of a wave. So a wave of like any type, sound, light, electromagnetic, visible light, any of them, they always go from up and down in a sinusoidal kind of formation, so like cosine sine waves. In the middle of them, this is known as like the baseline. From the baseline to the maximum of a wave, or from the baseline to the minimum of a wave, this is known as the amplitude. And this decides if the sound is going to be loud or soft. The tops of the waves, so at these like 3 points in this given wave, these are known as the crests. And the minimums of the wave that occur right here and here, these are known as the troughs. One of the most important concepts for waves is to know their wavelength, and the wavelength can be found from going from one trough or one crest to another crest, or from one trough to another trough. And this is denoted by the symbol lambda. Alright, so now we're going to talk about single slit and double slit diffraction. So single slit diffraction is when you have a single laser and it's pointing through a slit with only one opening. So here, the laser is going to go from here to right there and right there. So when this spreads out, this is going to make a diffraction pattern with a maximum right here, and then it's going to have a diffraction pattern like this. Now when we do double slit diffraction, the laser has more openings to go through, so it's going to go like this, 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 and this. So when the light comes out of each of these, it's going to create a diffraction pattern with a maximum here, and then even more crusts because of the interaction between the light waves. So if you look at the difference between single slit and double slit has a bigger diffraction pattern than single slit. So here is an example of interference in real life. So when I throw these two rocks in, the waves from both of them are going to interact with each other. Here you see constructive interference where the crest of one wave meets the crest of another to make a bigger wave, and destructive interference where a crest meets a trough. Shadows are a good example of diffraction as light tries to bend to go behind an object.